Okay, I just wanted to add a couple more things to the 3-7 day 2. I added a couple other examples on there. So if you've already watched the day 2, that's part 1. I guess we can consider this part 2. I want to talk about just a couple things really quick just to mention. First of all, when you have something like that first example we did yesterday for slant asymptotes, to do division, if you don't want to do long division when it's degree 2 over degree 1, you can do synthetic division, if you remember how to do that. So you just use the coefficients of the trinomial you're dividing, and then you're dividing by, remember the number, if it's x plus 4, that comes from minus a negative 4, so you're actually dividing by the negative 4. You take out the variables and you just do the long division, so bring down the 4, and then you multiply, which would be negative 16, and then you add negative 10, and then multiply again gives you 40, and then you add. So you can get all the values a little bit quicker. So this would be the remainder. This is your degree 1, and this would, or sorry, degree 0, and this is the degree 1 term. So that means it would be 4x minus 10. So your slant asymptote would be y equals 4x minus 10. So if it's degree 2 over degree 1 and you want to do synthetic instead of long division, you're welcome to do that. All right, then the last ones I wanted to do were these two on your note sheet. So we didn't have those on the first part of the day 2 video. So let's take a look at this one. So find all the asymptotes for this graph. So first of all, the vertical ones are always going to come from where your graph is undefined. So the possible vertical asymptote, I would set the denominator equal to 0 and solve. So I'm thinking that, okay, well, it might be at x equals 2. However, if you actually factor this and take a look at your equation, this would be what? X minus 3, x minus 2. That x minus 2 factor is removed, and you end up getting the equation y equals x minus 3. So this x equals 2 is not a vertical asymptote, so it's not one of those. X equals 2 is actually a point discontinuity. So if you take a look at the graph for this one, so if we graph it on your calculator here, I'm going to see if I can type over and just make this a little faster here. So x squared minus 5x plus 6, and then in the denominator, x, yeah, there we go, x minus, see if we can get the minus there, 2. Okay, go ahead and graph that and see what that looks like. So you're going to see that it basically just looks like a line. There's no vertical asymptote. If you go to your table, it definitely says error at 2. That would be a point discontinuity. So when you draw the line, there's going to be an open circle, then it keeps going. So we have no vertical asymptote. Normally then you would say, okay, the degree in the top is 1 bigger, right, than the degree in the denominator, so there'd be a slant asymptote. This is kind of the extreme case that when you divide out, it has a common factor. There actually isn't a slant asymptote either. It's just a slanted line. So if you end up with removing that discontinuity, you end up actually just getting y equals x minus 3. You look at the graph. So there's no slant asymptote either because the graph is a slanted line. So that's kind of the extreme case there. So there's no horizontal or slant for this one because it actually is a slanted line when you graph the equation. So kind of a unique case. So if that factor divides out, you're ending up with a linear equation. It's just that line. Okay, and this is the last one. I had it written a little bit differently on the other notes video. I already had it factored out, but I want you to take a look at it from the way that it is written on the note sheet here. So x squared plus x minus 6 over x squared plus 2x. Determine all of the asymptotes for that graph. Well, so first of all, let's look at the denominator for the verticals. If there are any factors that make the denominator 0, that's going to be your vertical asymptote. So for the vertical, I'm going to set that equal to 0. And I'm going to solve. So plot an x. That would leave an x plus 2. So my possible vertical asymptotes would be x equals 0 and x equals negative 2. Now I'm going to go ahead and factor this and just make sure that neither of those are removable. So on the top, we'd have what? X plus 3, x minus 2. So neither one of them are removable. That means both of these are vertical asymptotes. So this graph actually has two. All right, now, does it have horizontal or does it have slant? If you look at the degrees, they're both two. They're equal. They're balanced. So it's not slant. It would actually have a horizontal asymptote. So let's take a look at horizontal. All right, if you do end behavior for this graph, y approaches what as x approaches plus or minus infinity. Go ahead and take a look at the graph it on your calculator. I believe as you look at this graph, it should get closer and closer to 1, which means our horizontal asymptote would be y equals 1. If you remember what we talked about yesterday, if the degrees are equal like they are here, if they're balanced, that means the horizontal asymptote always goes to the ratio of those highest degree terms. So it looks like it would be going to 1 then. So we have two vertical asymptotes, 0 and -2, and one horizontal, y equals 1. So there wouldn't be a slant at all because we don't have a degree bigger by 1 in the top. So how do you know you have a horizontal? Kind of wrap this up. There'll be a horizontal if the degrees are equal or if it's bigger in the bottom. So if it's bigger in the bottom, it goes to 0. If they're equal, it goes to the ratio. You'll have a slant if it's exactly one bigger in the top and you don't have what's happening in that last example where it divided out. So slant is the one bigger. You can't have both. It's either slant or horizontal. And remember, the vertical always come from the undefined places. So that should wrap up everything we need to talk about for part 2. So part 2 of part 2 in the books.